Hey, hi. Today, me and my teammate are going to present a project titled Information Retrieval for Customer Service. In today's digital economy, customer service is a front line of user experience. Like, it explains the most resources, like intensive areas for an organization. Like, customers expect instant, accurate, and empathetic responses. So these are all automation powered by information retrieval and natural language processing that makes a massive impact in today's world. And our project, it introduces about the retrieval and the response system powered by a hybrid semantic and keyword search pipeline, and it retrieves information and analyzes customer sentiments and routes the tickets to the right teammate. So even it also replies automatically, like when it's confidential enough, like the information when it's confidential enough. And this project, it was developed by Dinesh Nagtej, my teammate, and my name is Shreya Guburi. As part of our informational retrieval course project, the ultimate project is like the goal is like make customer support smarter, faster, and make human like but without the human bottleneck here. It emphasizes this kind of, and uh, and also the goal and problem statement. It says the primary goal, like the system is to build an intelligent support assistant that understand the true intent behind customer queries, like not just matching keywords. So the traditional customer services chatbots often rely on exact key matches, like that means user faces something differently, like for example, my payment didn't go through instead of billing issue. It says like this: the system fails to retrieve the right answer. We wanted to fix that gap actually. So our system automatically retrieves the most relevant FAQ answers, like it detects the intent and sentiments, and then decides whether the auto respond or escalate to the human is an agent. Like it explains a structure that the project around three pillars here. The three pillars here are like accurate retrieval, smart tragic, and intelligent routing. This explains like matching user queries to the most relevant knowledge based entries, like when faced in new or informational ways in accurate retrieval. And the smart triage is detecting intent and emotion to decide whether the internal team is a like billing, tech, or support should handle the issue. This is kind of a team here. And intelligent routing here, automatically deciding when to reply or when to pass it to a human based on confidence levels and the sentimental polarity here. So in short, I can confess that it's not just about answering questions, but about understanding users and responding intelligently. Here, the third slides, it says the data set and knowledge base. Here, this system works effectively. We needed a reliable knowledge base and evaluational data set. Here we curated data set of 20 questions, like answer pace across multiple service categories: billing, account, shipping, returns, technical support, and subscription. This became the heart of our FAQ style knowledge base actually. And we also designed two evaluation test sets, like the baseline test set with 20 label questions that closely match the FAQs frequently. These tests are core retrieval accuracies. The paraphrase test set, it explains 18 queries with written differently, like using synonyms, abbreviations, and rewarded like phrases to set how well the system generalizes beyond exact wording here. And we also created and crafted annotations to simulate a controlled evaluation environment here. And these annotations helped us measure system performances precisely, such as identifying when retrieval succeeded simultaneously but not lexically. Essentially, we will not just do the testing whether the system could find an answer, but whether it could understand language variation here, the way real customers actually speak. The step 5 slide, that's tools and libraries here. We used the Python 3 environment using Google Colab for experiments. We intentionally choose open source tools to maintain transparency, flexibility, and reproducibility. Our core technologies included RANK underscore BM25 for lexical keyword ranking, and the Centrins transformers for semantic similarities using mini LM embeddings, and transformers for zero shot intent detection, and NLTK for text tokenization, and VADR sentimental analysis. For supporting libraries, we relied on PyTorch, NumPy, Scikit-learn, and the Python PPTX. The PyTorch for deep learning framework for embedding generation, and the NumPy like NumPy for effective vector and matrix operations. And the Scikit-learn, it evaluation matrices and utility functions. And the PPTX we use to generate some of our presentation visuals, automatically integrating analytics directly into the slides. The entire tech stack was designed for experimentation, and also we could easily swap models, adjust blending parameters and new evaluation layers without breaking the architecture. And the real world relevance, it helps, like, now let's talk briefly about why this matters beyond. And the customer service systems today are overwhelming by volume, like banks, airlines and subscription platforms get thousands of queries daily. A well designed IR based assistant can reduce human load and respond 10x faster and maintain high consistency in this mainly. And imagine, like, a system that can instantly interpret, hey, my refund still hasn't arrived, so identify it as a billing issue with the frustrated sentiment, and retrieve the refund policy and decide to escalate automatically. That exactly what our system architecture enables here. It blends retrieval accuracy, linguistic understandings and emotional intelligence, making AI support assistants generally useful rather than robotic. And from here onwards, my teammate continues it. Thank you.
A news style paragraph about interest rates and inflation, a research abstract style paragraphs about transforming based key phrase extraction, and a product review described strengths and weakness of a device. Each documentation is roughly around 60 to 120 words to keep the demonstration focused and readable. To create a simple evaluation framework, I manually selected 3 to 5 goal key phrases for each documentation. These goal phrases reflect that as a reader, consider the salient terms for the text. They provide a target for each match metrics like precision 5 and recall 5. Because these texts are rather than form a formal datasets, I emphasize that my evaluation is illustrative. It's designed to highlight differences among methods quickly, not to produce deficient benchmarks. Even if I had more time, I would expand the public datasets such as InSpec, SemEval. In terms of sourcing, the texts are either paraphrased or lightly adapted for common topics. If I include any additional snippets for public articles or abstracts, there's the resources in the slides or notebooks. Maintaining clarity about the origin of text helps avoid ambiguity. So the methods and implementation I used here is, it starts with the minimal preprocessing. I normalize white spaces and load English stopwords via NLTK. I intentionally avoided aggressive cleaning because punctuations and phrases boundaries can be useful for identifying multi-words expressions. I run rake first, which identifies candidate phrases by using stop word boundaries and co-occurrence statistics. Rake tends to surface meaningful collaborations, especially in well-structured text, and if often generates interruptible multi-word phrases. Next, I apply Yake, which sources candidates using unsupervised features like term frequency, position, chasing, and disparity across the documentation. The domain and can produce results that balance unigrams and short phrases. I then use TextRack via the summon package. TextRack builds a graph of event connected by co-occurrences, then ranks nodes using a page rank like algorithms. So finally, I run keybert with generates candidate phrases and select those most similarly to document using embedded sentence formation model. So all the outputs with the single run all functions and present side by side, followed by the simple precision 5 and recall evaluation. So the qualitatively, I see the keyword frequently surfaces multi-word phrases with align well with human intuitions such as interest rates, persistent inflation, or key phrase extraction. These results reflect its ability to leverage semantic similarity from embedding rather just frequency or graph structure. Rake performs well at identifying collocations that emerges from stop word development segments, making it stronger on phrases like rate cuts or battery life. So the text rank tends to produce a silent unigrams such as inflation, market, or transforms. While these single terms are often correct, they can be less informative than multi-word phrases. In my small evaluation using extra exact matches, keybert often leads to precision of top 5 phrases, with the rake and yake competitive depending on the documentation type. Technically, abstracts shows the advantage of semantic methods, while new styles and review style text sometimes favor rake or yake because of clear phrase boundaries. So I also noticed practical factors. Keybird has a small initiative overhead while downloading the embedded model, but it's faster thereafter. Rake and Yake is consistently quick. Text rank is efficient, but sometimes less useful for multi-word phrases discovery. Across all methods, the minor parameters tuning can noticeably improve quality. So the example output comparison tells the comparison results for a sample news documentation about economic policies showing distant extraction patterns. You see various methods like rake, yake, and text rank and keyword has different keyword phrases, has a phrase types and a semantic quality. So the main intake is that no single unsupervised methods dominates all scenarios. If I want coherent multi-word key phrases quickly, keyword is a strong default. Rake and Yake provides a lightweight, reliable option where I need speed and simplicity. And TextRank offers a robust single-term challenge. Practically, I would combine methods or tailor them into the domain. For example,